Hi everyone, I just wanted to share a quick video showing one of the agentic workflows that we're going to talk about through the conference. So start off just with some infrastructure. So we can see here on the left, this is a normal, host machine. So like a normal laptop or a desktop. And if we had, let's say, for example, an agent on that, just straight onto our host machine, then the agent's going to have access to our file system. And it's also going to have access to the internet. So that's not really a safe setup to have because, the agent can do damage to the file system, but also it can extract, files and put them onto the internet. So, if somebody was to, for example, get control of our agent, then that would definitely be a massive security flaw. We've all heard this horror stories of, file systems being completely deleted by these agents. So yeah, this is really the kind of setup that's going to lead to that. And especially if you give the agent full control and you don't, ask it for approvals before it does anything. So over on the right-hand side is the kind of infrastructure that I would normally use to try and, limit the damage that these things can do. If anything does go wrong, then they can't really do any damage. So we have the host machine, we have the file system like before, but now we have this Docker engine or some kind of abstraction layer, something that's going to run virtual machines. And lightweight virtual machines are known as containers. So if we have something like a Docker engine, we can run these lightweight containers, and these are basically like little computers. So I have, each container can basically look like this host machine here. So it can have an agent on it, and it can have its own separate file system. And also what it's doing is it's using the resources of the actual host machine. So this little computer uses the CPU, the GPU, the RAM, everything from the host machine. So in this setup, it's a lot safer because the agent can talk to Docker, and Docker can say, you're only allowed to visit, let's say my agent, I give it access to my Gmail account, then it can only access that. So I can basically, I have full control over what the agent can or cannot access, whether it's, on purpose or by mistake or whatever, because it will have its own virtual network. So the network is abstracted, and it also, like I say, has its own file system. So if it tried to delete a file system, for example, the entire operating system's file system, then it's not going to do any damage to the host machine whatsoever. It's just going to damage the container, and the container can just be deleted, and then you can spin up a fresh one. The same with your local models. So the local large language models, I will normally just run them in a separate container. So the Docker engine can, maintain the local model, but the local model doesn't need anything from the file system. So it's really just interacting. It's basically the muscle behind the agent, or the brain behind the agent. So the agent is making its request to the large language model, and then we are basically controlling very carefully what it can and can't do through the Docker engine. And there's other things as well, that we're going to look at. Basically, the main security feature for all of these systems is going to be the human in the loop. So before they can take any kind of action, you need to have some kind of point there where it can't do any action unless it gets approved by a human. And it has to show the human, this is what I want to do, and it can only do that. So this is, like I say, this is my kind of setup. So what I'm going to do is just go through a quick demo of just a basic agentic workflow that I have set up just as a demo. And like I say, we'll be talking a lot about this during the conference. Okay, so we'll we can spin up the Docker containers with this command. And this is basically just going to run the file that I have that says to create the containers. So I'll be sharing all these files anyway. So the first time that it runs, it will download this is the container here, the Olama one. That's the large language model, the local large language model. So you can see it's healthy, it's running. The invoice agent, so the workflow that I've went through is an invoice workflow. I'll show that shortly. And then this container was basically just to make sure that the large language model has been downloaded to this container. So that's why it exited. So we'll have a look at, we can go over to Docker here. You can see these are the two containers. So that's the large language model running, and that's the agent itself. So if we go and look at the agent's logs, you can see it has already started. So it'll check Gmail every Monday at 9 o'clock, and the agent is, so there's a scheduler and an agent, and the agent's running now, and it's listening for Slack messages. So Slack is just, a communications channel. We could hook up, Discord or WhatsApp or whatever, but this is a way that we can talk directly to our agent, from basically any device. You can get Slack on your mobile phone, for example. So you can see here the agent send type process invoices into Slack to trigger the on-demand. So the app is running. Okay, so that looks good, and I'll just get this down and show you what we have. So this is Slack here. As you can see, I've been doing a lot of testing. But what I basically have is a test email inbox, and I am getting, invoices here that are attached to emails. So the workflow is that the agent is going to, as soon as I, give it the go ahead, it's going to scan the inbox for any of these invoice attachments, anything that looks like an invoice, and then it's going to extract that information and it's going to put it. So this is, an example of what the invoice would look like. And I have this spreadsheet here, Google Sheets. As you can see, this is the information that it's going to extract. So it's going to take the vendor's name, the invoice number. As you can see, there's the invoice number. We have the invoice date, so it should grab that information, the due date, and then the total amount as well, and the currency. And then also we're going to timestamp when it was processed. So that's essentially what it's going to do. Once I say go, it's going to look through the email inbox, take the invoices from any emails that it finds that it has an invoice, and then it's going to extract the important information. It's going to log it here, and then it's going to send reminder emails to the people in the accounts department. So as this is just a demo, I have all dummy email addresses and everything put in. But essentially, before it does any writing to the spreadsheet, or before it sends any emails, or before it does anything, it has to ask for approval. So we're going to look at that, see how that workflow works. So the agent is up and running. In Slack, what I can do is I have a shortcut coded into Slack, so I could just do /. You can see my shortcut straight away, process invoices. But I could just type in process invoices into the chat there. So it has replied straight away. Okay, so happy days. Let's go and look at okay, you can see it has started analysis. These are the logs. So it has found 2 invoice emails. Brilliant. And yeah, I've sent both of them. So you can see it's got the sender and the sender's email. So we can go back over and have a look at this thing in action, and then start to see, can we test to see is it doing things correctly. So because this is a local model, it's going to take a while to run the LLM. So I'll open Docker and just talk about that for a second. So as you can see here, the LLM container is starting to ramp up in terms of its CPU usage. And, it's using a lot of memory there as well, in terms of the main memory, and then, the writing to disk as well. But all of that, we can limit that. So I can reduce the amount of memory or the amount of CPU, that each container is consuming. So let's say if they're, consuming too much of my resources, I can just ramp these down. So that's another layer of control that I have. I can give them or, take away resources as I see fit. And because, as you can see with my machine, I've got about, 15 gig of RAM that's available, and 12 CPU cores that are available. And yeah, for something like this, it's going to take quite a while. But the whole point of this kind of type of workflow is that you still have the security of the local language model, and it doesn't have access to any of your files or anything. And even any of the tokens or any of the things that you're feeding into it, even though that might be, highly sensitive information, there's no way that it can get back out, or the model can't be trained on it. That model is completely disconnected from the internet. So it's a lot safer, but we're trading up that safety for speed. So we're losing the speed, unless you have a really good laptop, but mine is just, a standard one, so it's going to take quite a while. And you can see here, it's already using like 6 cores. It is probably loaded as much of the model into memory as it can. These models will load all of the full model into VRAM, so it's the GPU's RAM. And if you don't have a good GPU like my machine, then what's going to happen is the model is going to be switched in and out of the VRAM, and it's going to be saved into RAM. And that's this memory usage here. As you can see, it's using quite a bit because it has to switch in and out from the GPU's RAM. And then that's why the CPU is being ramped up, because it's doing a lot of switching between main memory and then, the GPU's memory. So yeah, we're keeping the security and the safety, but we're losing the speed slightly. But it's worth it in my opinion. So as you can see, we're still waiting, and it does take quite a while. And we'll probably see as well during this demo that these things don't always work. Hence why you need to be using these, safe infrastructures and build these systems and build these workflows safely, so that if something does go wrong, you always want to build for the worst case scenario, so that if something does go wrong, if worst case scenario does happen, then you don't need to worry about it. You're not really going to lose the house, as they say. You're pretty much protected, and there's what's known as the blast radius of the agent. The amount of damage that it can do is completely contained. So they're a lot safer if you can use these type of workflows, but we probably will see it messing up here somewhere along the line. When I was testing this workflow, I've tested it quite a bit, and because they're the free models and because of my limited hardware, it will make mistakes. It'll make a lot of mistakes. And we do have the more powerful models now that are making less and less mistakes, but they cost a lot to run. And then you don't know what the companies that are running cloud models, you don't know what they're doing with your data on the servers. Are they making copies of it? Are they using it to train the models? There's loads of different kind of unanswered questions, and some of them questions are becoming answered as time goes on, but it's a slow process. So I find that it's just safer to keep things local and keep things contained, so that if anything does go wrong, then it's not the end of the world. So in this test, in this demo, I have an example or a test email account, Gmail account. So I'm doing this all through Google's API. So accessing the emails through Gmail, and then accessing the Excel spreadsheet basically through Google Sheets. So this would work, for any kind of, as long as you have the correct APIs, then it should work okay. So as you can see, what has happened here, we have a tool called Read Invoice PDF, and it has come back with the text from the PDF. So let's see, this one is Peak Digital Marketing, and is that the one that we had? Yes, Peak Digital Marketing. So it looks like it's off to a good start. That was 7,800 total, and it had 78. Lovely. So that's a good start. So it needs to read the invoice. It has to read the text from that, and then it's going to have to extract this text. And then once it does that, it's going to have to get it ready to put it into the spreadsheet, but it's going to need to ask permission to do that. So before it's allowed to do any kind of writing or sending emails or anything like that, it has to ask for permission. So basically, if you want these agents to have agency and to execute tasks, then you really do have to be careful, because you don't want them to be able to execute a task that you don't want executed. So you basically, every time that they're going to do something that is going to be basically a write operation, if it's going to be able to write anything anywhere, then you need to be able to check what it's writing. You need to be that human in the loop. And the whole point of giving this Slack channel, kind of doing it in this way, means that once this architecture, once this infrastructure is set up, then we basically can, let it run itself. The containers will update automatically and everything. And if there's any new security updates or anything, it'll all be updated automatically, because, for example, the Olama container is, that's managed from that company. So if you look here, this is the latest image. So you just use the latest in everything, and it will basically update itself. Okay, see, this is it has made a mistake here. So you can see already they're not perfect systems. They're still experimental at this stage. But the best we can do is put these guardrails in and try to limit the amount of mistakes that they can make. So I have things like, I have some guardrails, in this workflow. For example, if it does things like this, then I get it to retry. Or sometimes what will happen is, if you don't have the proper agentic model, some of these models will start to tell you what they're thinking about doing. With the agent models, what you need really is things like this, where it's just going to call a tool. it's not going to start thinking about what it's going to do, or it's not going to, it's not going to start giving you all of its reasoning why it did what it did. You just need it to do what you've asked it to do. So things like that, the tool call. Sometimes the text will come back, I need to call the read invoice PDF tool. So obviously that's not calling the tool. So again, depending on the model itself, you can see this one it's supposed to call the tool, and then it's actually supposed to check for a duplicate to see, is this invoice already in the spreadsheet? And once it gets past that check, then okay, sorry about that. I had to restart because everything just crashed. I'm trying, I think, too hard on the computer. I have two screens, and I'm trying to record my screen and also run a large language model. So forgive me if it does crash a few times. So as you can see, this time it has found the two emails again, but this time it hit one of my guardrails. So I have it trying 3 times to basically call a tool, because these, like I said before, the smaller models, some of them can just start describing what they're going to do. So I put this in to basically scrap whatever the model said and ask it again. Okay, so we can see that it has, right, let's have a look before we go to Slack. So it has completed the analysis. It got the PDF, it checked if it was duplicate, and it done that based on the invoice number, and it said that no, it's not. So it completed the analysis. Now we have the output of the check duplicate. Let's proceed with analyzing. So since the invoice is not a duplicate, we will perform the urgency and amount checks. So first of all, it's going to calculate when is this payment due. So it has got today's date correctly, and it's got the due date. We'll check that now in a minute. So it's calculating that, that's okay. So 7 days remaining, the invoice is not urgent. Okay, so we said the rules were if it was less than 5 days. So looks like it's doing okay so far. And then this is less than or equal to, right, I got that wrong. So 7,800 isn't less than. So we do need an urgent reminder there. We have a rule in that if there's an invoice above 5,000, that there should be an urgent reminder sent. So it failed that one. So it has sent one action for approval. So its proposed actions are just to log the invoice to Google Sheets. So let's approve that action and see what it's going to log for us. Did it actually get the correct stuff? So as you can see here, we have nothing yet. Okay, there's the message. My computer's just taking a second to load. So the vendor is, let me get these up. Peak Digital Marketing LLC, yes, that looks good. And the invoice number looks good. The amount is good. And the currency, yes. And then the due date, yeah, that looks good. Okay, so I can approve that. As you can see, it's giving me things here I can review. And then it's telling me what it's going to do. So I can let it go, or I can say, no, don't do that. So we'll go with approve to see, will it do that properly? So again, if this was on your phone, right, so it said it has done it now. But if this was on your phone, that would just, pop up as a message from the agent. So let's go over and see. Okay, yeah, it got digital marketing. Invoice is okay. The invoice date, it got that as well. Lovely. It didn't give us that for approval. Okay, and the timestamp and everything, yeah, that all looks good. Apart from, it didn't get that check. It didn't understand that 7,800 was more than 5,000. So yeah, that's, one kind of, you could see there that you would need to put maybe more guardrails in for that. As this is just a demo, I've only got guardrails in for, the most critical things, but not really the business rules per se. If you wanted to do that yourself, you can follow the tutorial that I have along with this video, and you should be able to see where you can put in your own business rules. So let's go back and see what it's at now. Okay, so it got approved. So it executed logging the invoice, and we've seen that. And it checked the result as well. Okay, and then it marked the email as read. Let's have a look at that. Maybe my computer, oh, it did. Just took a second to upload. So that first one's marked as read now, so that's that one processed. And we have, the most important information. That one part of the workflow failed, but like I say, there will be, when you're building these workflows, there will be loads of, you'll need a lot of testing, and you'll need to really test it as much as you can to see where all its weaknesses are, and then try and put guardrails in place, to stop those weaknesses happening. And there's things, like RAG systems, retrieval augmented generation, where you can store large amounts of context and, even loads of documents. If you store it in a certain way, then you can feed it into these models in a more efficient way in terms of token usage. So you can start to basically give them a brain and a memory, and then they stop hallucinating, and they stop misbehaving as much. So it's all about the guardrails that you put in. That's really the main kind of point that I really want to get across, is that these things, although they're powerful, with great power comes great responsibility, as they say. So we do have to be careful, and we have to be very responsible when we're using these, because there are times, there are things that can go wrong. And I suppose I want to show that as well in this demonstration, that, even because I haven't had time, to test this completely and fully the way that I should, if it was a production system, then there's obviously going to be loads of bugs in it. So, but again, it's good for a demonstration, and it's good to show you. I think it's good anyway to show where the weaknesses are. So here you can see again, it has failed at that tool call. The first thing that it should do, if we go back up here, it should call this read invoice PDF tool. So this agent has been given a list of tools, and tools are basically just functions that it can run. Things that, are common, that are going to be done over and over again. For example, if I was converting a PDF to a Word document, if I found myself doing that all the time and asking the model to do that all the time, I can just bake that into the model. And that's essentially what you're doing. You're giving these things agency. So, and I can give it this workflow, right? So read the invoice, and then the next thing it should do is check if it's a duplicate. And then the next thing it should do is, if it's not a duplicate, do these checks, the urgency and the amount checks. So urgency in terms of when is this thing due to be paid? So that was right on 7 days. We had, if it was less than 7 days, so that was kind of borderline, and it got that one right. But like I say, then the amount one, it didn't get that. Total amount is less than. So at this point, it should have sent an email to finance, my pretend finance department. And if this one was triggered, that would send an email to the manager in finance. So yeah, it got one of them wrong. And like I say, this is just a small workflow, where I've given it a couple of tools, a couple of small functions that are common enough, and just say to it, right, call this tool, call that tool, call the next tool, call the next one. I've just given it that workflow. And sometimes it does it, sometimes it doesn't. So here we go. It looks like it is grabbing, yes. Yes, that looks good. Let me see the second invoice, Metro Cleaning Services, yeah. Okay, so it looks like it's grabbing the information, okay. 1520. Consumables, restocking, yeah. Bin liners, it takes in the escape line when that goes on to the next line. So yeah, that tool is working now, so we can, hopefully the check duplicate will work. There shouldn't be a duplicate, and I was going to show that working. It does work, but I might not get to show it. It depends on how long my computer lasts. So we can see, I tried to read the invoice again. So I have a guardrail in for that because I've done that before. So yeah, I've basically said to it, don't do that. Just go to the next call, and it has done the next one. And it's found that it's not a duplicate, which is correct. Let me see, did I get the right invoice number? Yeah, it did. I'm not giving the model any context, like I'm not pointing it and saying this is where the invoice number is. It has to reason, because this is essentially, you could be all different formats and different types of invoices. But if you were sending things out from your business, and it was your same format, then this could be made even more accurate. You could say to it, you could basically point it exactly where the information is. If you know that, say, for example, the date is always going to be here, and things like that. So what has it to call next? Let me go back up. Yeah, it has to work out the urgency and the amounts. That's right. So it knows now that it needs to be logged, and it's probably going to ask me for approval soon if it gets through them other checks. And these agents are as powerful just as the models that back them, really, because what I'm doing in the background is it's an agent flow, or an agent loop, as it's called. So the model, if I go back here and show this, the agent essentially can just keep asking the model. It can keep saying, "Oh no, give me this," and then the model gives it back, and the agents, it can check and say, "Right, did it give me the right thing?" And then it can go, "No, it didn't." So this is the agent loop, is really where it can observe, think, and then act. So observe mean, taking in your prompt. What is it that you're looking at to do? So whenever I just put in process invoices into the Slack chat, then it can basically say, right, give me that tool that you have where I can read the PDF, and then call that tool. But these LLMs, the local ones, especially because I have to run a smaller one on my hardware, it's going to kind of get confused and say, all right, or, some of them start thinking first. They'll start thinking about what they need to do, and then they will send it back, an answer. But what happens sometimes is it sends back what it's thinking back to the agent. So it sends back the wrong thing. And that just is how, another example of how these LLMs can get confused if you don't ask it the right thing. So what I have been doing in terms of testing and trying to make this model give me exactly what I want, it's essentially prompt engineering. So I have to have perfect, as accurate and as specific prompts as I can. So I tell it exactly what to do, and I tell it, don't have any assumptions either. So there's loads of guardrails that we can put into the agent, and the agent is kind of the thing that's overseeing the large language model. But say if your host machine was, if you were deploying this on your own data center, for example, then you could probably have, so if we had, what we could do is, have loads of containers, and we could have maybe a Docker container that had loads of containers inside it, and you can have, containers within containers. So that's kind of doubling up your security, and also having this kind of setup where the agent can drive the large language model. So if we go back and look at the right, so it sent us something to Slack for approval. Let's see what it was. 3200 it grabbed out, and that is less than. Okay, that's correct. 5 days is greater than 7. Yeah, that is urgent. So got that one wrong this time. The duplicate, it was false, that was correct. So let's go and see on Slack what it has given us. Right, we'll get the invoice up. Metro cleaning services, yeah, that's correct. The invoice number, the amount, the currency, and the due date. Yeah. Okay, we'll log it. It should be sending emails at this point, but the reasoning isn't come back correct for the mathematics. And that happens sometimes with the agentic models. They're more code-based, so they're not really good with the reasoning. Okay, so let's have a look to see what... Oh, there we go. Okay, invoice date. Yeah, that was correct. Okay, so it logged that. It just didn't send any of the emails that it was supposed to. But I have been testing it, and yeah, trust me when I say it has been working. But that's the thing, sometimes these things don't work, and it's good to see that in action as well, because they do need to be tested non-stop. And even when you do think that it's absolutely perfect, you do always have to have this, this kind of in place here, where you can approve things or stop the agent doing what it's doing. So as you can see, I'll go back to Docker, and yeah, so it's done that. Yeah, it logged everything, email marked as read, and then you go back. And we can see the large language model isn't really doing anything, so that's good. We have the agent that's controlling the large language model, so it's not going to do anything unless we ask it to. You can see it's not using anything now. So yeah, that's in my opinion a far better approach to starting working with these workflows. So for this, I might try this one again just quickly if my computer can hold out. Okay, that was, so we'll mark this as on red, just to make sure. Yeah, that's it on red. And then I'll type in the, if I was on the phone maybe and I didn't want to go in and get the backslash or the forward slash, I just type process invoices. The agent came back. Okay, starting. So it should only find one this time, and it's hopefully this one. Okay, so it started the large language model anyway. You can see that's ramping up. Okay, it found the email. So this is actually a tool that is calling here as well, where it's basically just looking for emails that only have attachments, and then it's reasoning, is this attachment an invoice or not? So it won't go for all on-read emails. It'll only go for the ones that it thinks are invoices. But even if you were doing a system like this, and building this agentic workflow, I would still have, like I say, a container within a container, and also have a practice, a kind of a dummy email account that it's not going to be able to, go through your contacts or go through your photos or go through all of your business emails. You don't want it having any access to anything like that. Even when you fully trust it, you still, like I said, always say, you need to have that final layer of security there, which is always going to be the human. It has to be with these things. So we'll see how it goes. This is really just to test that duplicate tool. So it has to get through the extracting the PDF first. This bit I'm going to fast forward in the video. Okay, so we can see that it is reading the PDF first time. And peak digital marketing, that's correct. The 7800, that's correct. So if it is duplicate, what it's going to do is it should send an email to the finance team, basically just saying, here, this one has already been done. Okay, we can see that it has figured out that this is a duplicate. So let's see what it does now. Okay, so we can see that analysis completed, and it's going to start to reason. So since it was returned, propose send it instead of log invoice. Okay, send the warning. I've done the urgency check and the amount check. Got that one right. Got that one wrong again. But anyway, so it's proposing to log the invoice. That's not good. So it has given us two actions. It shouldn't be proposing to log the invoice because, as I said here, it should be sent in the warning. It's sending that, okay. but instead of log the invoice, which is correct. But down here, as you can see, it's not doing it right. So this is a good example of let's see, it's got the correct information out and everything. Okay, so it looks like it's got all of the right information. So if I was to log it, it's going to clash, so that shouldn't be. It shouldn't be recommending that. So if we send a warning to the finance team, okay, so we can see it executed one thing and it skipped another. So that's a good example of where you can, control it and say you're not allowed to do that action. So if we go here, did it log another one? No, I think we're good. Okay, so that worked. And it processed that. And then yes, duplicate invoice, please disregard. Brand new email. So that's one example of a simple agentic workflow that, as it says here, nothing will execute until you approve, and the AI runs locally. Your data never left it. So that's, how you can get a kind of good infrastructure that is safe. So that's pretty much it for the agentic workflow demo. Like I said, there's a tutorial along with this video, and you can download the code from GitHub, and you can, try this out yourself and get it all working. The tutorial will take you through how you set up Slack, how you set up the Gmail hook, how you set up the Google Sheets, and the code has all of the logic and everything, so you can play around with that. And it also has the Docker files, or the Docker Compose files, basically the text files that will build your containers. So all you really need to do is, the same as what I did here, the Docker Compose up, and that's it. It's basically just one command in the command prompt. Okay, so thanks for listening, and I look forward to meeting all of you at the AICON in Canada. Thanks.